the instantaneous acceleration. Instantaneous acceleration, a formula dv by dt or v into dv by ds or ds square d square s by dt square. These three formulas we can use to find the instantaneous acceleration. That is completed. Next, after that, displacement time graph, velocity time graph, acceleration time graph. What are the uses of that? Let us see about this. First of all, what is meant by displacement time graph? Displacement time graph, what is the meaning of that? See. So, if a graph is drawn, by taking displacement on y-axis and time on x-axis. So, independent variable that will be taken on the x-axis. Dependent variable that will be taken on the y-axis. So, displacement will depend on the time. That's why by taking displacement on the y-axis, time on the x-axis, if a graph is drawn, then the graph is called displacement time graph. Then the graph is called displacement time graph. Clear? This is the definition of displacement time graph. What are the uses of this displacement time graph? Why we are using this displacement time graph means, by observing any graph, we can state about the state of the body. We can say about the state of the body, whether the body is at rest, the body is moving with uniform velocity, body is moving with uniform acceleration. To explain the state of the body, this graphs will be useful. So, what are the uses of displacement time graph? Okay. What is the first use will be the slope of the tangent at any point. The slope of tangent at any point gives instantaneous velocity. Slope of the tangent at any point. So at any point, if we draw a tangent, then the slope of that tangent, it will give instantaneous velocity. Next, the slope of the chord. The slope of the chord between 2 points. The slope of the chord between 2 points gives they will ask slope of the tangent at any point will give instantaneous velocity. In the same way, slope of the chord between 2 points, that will give average velocity. Okay? How many types of graphs are there? From the graph, what we can understand? See. So, for this, divide the page into 3 columns. First one will be context. Second one will be shape. Third one will be comment. So first one will be context. Second one will be shape. Third one will be comment. Okay. So first one, context. Particle is at rest. Particle or body. Particle is at rest. Then draw the displacement time graph. Means particle is at rest means what will happen? Position of the body is not changing with respect to time. Its position is not changing. It will have the same position at all times. So if this is T, if this is displacement, graph shape will be like this. So shape of the graph will be in this manner. Clear? So if displacement time graph is a straight line parallel to x-axis, what is the state of the body? Body will be at rest. Or if particle is at rest, draw the displacement time graph. Graph will be in this shape. So what we can say? It is a straight line. Parallel to x-axis. Okay? And here some x naught like that you take. X naught represent the initial position with respect to origin. X naught will represent the initial position with respect to origin. Graph will be a straight line parallel to x-axis. These 2 points we can understand from this graph. So how the process will be there? Try to understand what is displacement time graph. Taking displacement values on the y-axis, time values on the x-axis. If we draw a graph, that graph will be called displacement time graph. What we can understand from the displacement time graph? If the body is at rest, then what is the shape of displacement time graph means? It is a straight line parallel to x-axis. And what is x naught is representing? X naught is representing initial position of the body with respect to origin. Next, second. Particle is moving with uniform velocity. Particle is moving with uniform velocity. Then what is the shape of displacement time graph? Particle is moving with uniform velocity. What is the shape of displacement time graph? How it will be there? Graph shape will be like this. Clear? From this what we can understand, it is a straight line with positive slope. It is a straight line with positive slope. Clear? That we can understand from this. Next, 3. Particle moving with uniform acceleration. Particle moving with uniform acceleration. Particle is moving with uniform acceleration. How the shape of displacement time graph will be there? Okay. Graph shape will be like this. So what it is representing? So it is a parabola. What is the shape of the graph? It is a parabola with increasing slope. What is the meaning of that? See, so this is the graph now. Okay, slope means this angle made by it with horizontal. Comparing to this angle if you take, this angle you take, try to observe that angle, what will happen? This angle, if you observe, it is gradually increasing. So, graph is a parabola with increasing slope when body is moving with uniform acceleration. Clear? Next. Particle moving with uniform retardation means uniform with negative acceleration. If the particle is going, what will be the shape of this one? So shape will be like this. Okay, gradually slope will decrease with time. So it is a parabola with decreasing slope. It is a parabola with decreasing slope. Is it understanding how the process will be there? What is the shape of the displacement time graph? What is the shape of the displacement time graph? here what will happen? This angle, comparing to here this angle, what will happen to this angle means gradually decreasing. So, graph is a parabola with decreasing slope, graph is a parabola with increasing slope. Clear? Next. After finishing of this, vertically projected body. Vertically projected body means from the ground. A body is projected vertically up. This is ground, let it be. From the ground, one body is projected like this. Then, how its displacement is changing with time. So, gradually its position will increase, it rises to some height. Again, it will fall down. So, when it is going up, its velocity will gradually decrease, and finally it becomes zero. Again, its velocity will gradually increases and finally it reaches to the ground. If we draw the displacement time graph, in that case, graph shape will be like this. Okay? At different situations, graph shape will be in this manner. Clear? So, what is the shape of the displacement time graph? Means it is a parabola. It is a parabola graph shape. Okay? And slope decreases. Slope will decreases up to some position, and again it will increase. Slope decreases up to some position and again it will increase. Clear? This is the different types of displacement time graph. What we told up to now, listen. What is meant by displacement time graph? How many types of displacement time graphs are there? We are discussing. If displacement values are taken on the y-axis, time values are taken on the x-axis. If we draw a graph, the graph will be called as the displacement time graph. If the displacement time graph is a straight line parallel to x-axis, what it is representing means body is at rest. If it is a straight line passing through the origin, what it is representing? Body is moving with uniform velocity. If the graph is a parabola with increasing slope, then it will be body is moving with uniform acceleration. Graph is a parabola with decreasing slope, body is moving with retardation, uniform retardation, that is represented. For a vertically projected body, graph shape will be like this. Clear? Next. What is meant by velocity time graph? By taking some values, if we draw the graph, easily you can understand about the graphs. Next. Velocity time graph. What to say? In this, time will be independent, velocity will be time dependent. So So independent variables will taken on the x-axis. Dependent variables will taken on the y-axis. Try to define. If a graph is drawn by taking velocity values. A graph is drawn by taking velocity on y-axis and time on x-axis. A graph is drawn by taking velocity on y-axis, time on x-axis. Then the graph is called. Then the graph is called velocity time graph. Velocity time graph. What is the uses of this velocity time graph? Uses of VT graph. Okay, first one. The slope of the tangent at any point. The slope of the tangent at any point gives the instantaneous acceleration. Theory part all this is. Just we have to, theoretical questions will be there on this. We have to remember this all. The slope of the tangent at any point gives the instantaneous acceleration. Displacement time, what happened? The slope of the tangent at any point gives the instantaneous velocity. Here it will give instantaneous acceleration. Clear? Second point. The slope of the chord. The slope of the chord between 2 points. The slope of the chord between 2 points gives the slope of the chord between 2 points gives average acceleration. Okay, that is the second. Then what will happen? The slope of the chord between 2 points gives average velocity. Next, third one. Uses we are discussing. The area of VT graph will give the area of the VT graph will give the displacement in that time interval. The area of VT graph will give the displacement in that time interval. What is the meaning of that? If you draw velocity time graph, area means what you have to do means you have to multiply the two quantities. Velocity into time will be obviously displacement. Slope means what you have to do, you have to divide these two quantities. V by T will be equal to acceleration. Simple to remember, na? Slope means quantity on the y-axis by quantity on the x-axis. V by T is equal to acceleration. Area means V into T, that value will be equal to displacement. Okay. Next, after finishing of this, next types of VT graphs. Types of velocity time graphs. So what they will ask, body is at rest. What is the velocity time graph? Body is moving with uniform velocity. What is VT graph? Uniform acceleration, uniform retardation. Like that, different types of graphs will be there. We will discuss one by one. So divide the page into three columns. Context, first one. Second one will be shape. Next, third one will be comment. Theoretical questions will be there on this, remember. Okay. So first one, particle is at rest. Particle is at rest means what will happen? What is the velocity of the body? Zero. Velocity of the body is zero. So if we, with time, its value is not changing. So if we draw a graph between velocity and time, the shape of the graph will be like this. Means with time, velocity is zero, it is not changing. So what we can say, graph is a straight line. Graph is a straight line along x-axis. Graph is a straight line along x-axis. So if it is like that, then what we can say, body is at rest. Okay. Second one, body or particle, whatever it may be. Particle is moving with uniform velocity. Particle is moving with uniform velocity. Particle is moving with uniform velocity means its velocity is constant. Its velocity is not changing with time. Okay, then we can say which particle is moving with constant velocity. Meaning, so how the shape of the graph will be there means it will be like this. Clear? So what we can say here, graph is a straight line. Graph is a straight line parallel to x-axis. Then body is moving with uniform velocity. Okay. Next, third one. He is moving with particle is moving with uniform uniform acceleration. Then what will be the shape of velocity time graph? It will be like this. What we can say, graph is a straight line. What is the shape of the graph? What we can say, graph is a straight line with positive slope. Graph is a straight line with positive slope. Next. Slope is equal to acceleration. What is the slope of velocity time graph means? That is acceleration. U represents initial velocity. There in the velocity displacement time graph, x naught represents its position with respect to origin. Like that, here u will represent its initial velocity. Next, fourth graph you see, particle is moving with, if particle started from rest, how the graph shape will be there? Like this graph shape will be there. Okay. If particle is not started from the rest, then graph shape will be like this. If particle started from rest, graph shape will be like this, remember. Okay. What if this is representing particle started from rest and moving with uniform acceleration. A particle is having initial velocity and moving with uniform acceleration. This is the graph. Yes. Small difference will be there between the two. Next. Particle moving with uniform retardation. Particles start moving with uniform retardation. How the graph shape will be there means, it will be like this. Okay. Graph is a straight line with negative slope. Graph is a straight line with negative slope. Slope is equal to acceleration. Slope is equal to acceleration. These things we can understand from the graph. Clear? Next, one more thing will be vertically projected body. It is asked in one exam, 2018 or something, 1 year they asked. Draw the what is the shape of velocity time graph for vertically projected body. So this is time, this is velocity. Shape of the graph will be like this. 1919. 2019 they asked what is the velocity shape of velocity time graph for vertically projected body. Like that question is there. What it is saying? Graph is a straight line. Graph is a straight line with negative slope. Graph is a straight line with negative slope. Here what is the final displacement of the body means? Body started from one point and again it came to the same point. So net displacement is equal to 0. So the net area under the curve is 0. Means this area, this part area both will be equal and negative, equal and opposite. This is negative, this is positive. So the net area under the curve is 0. Clear? Next. Here if you write this is O, A, B, then OA value will be equal to time of ascent. AB value will be equal to time of descent. OB value will be equal to time of flight. So here OA value is equal to time of ascent. Formulas will come in the next topic. That value is equal to U by G. AB is equal to time of descent. That value is equal to U by G. OB is equal to time of flight. That value is equal to 2U by G. From in the graph, OA will represent time of ascent, AB will represent time of descent, OB will represent time of flight. Time of flight formula will be 2U by G. Time of ascent is equal to time of descent, that is equal to U by G. So what we are discussing up to now, try to understand. So displacement time graph, velocity time graph. What are the uses of them? What are the uses of displacement time graph? What are the uses of velocity time graph? For different situations, what is the shape of the graph? For vertically projected body, what is the shape of velocity time graph? For body moving with uniform acceleration, for body moving with uniform retardation, body moving with uniform velocity, body is at rest. What are the shapes of velocity time graphs, displacement time graphs? We discussed up to now. Okay. Next, what is acceleration time graph? Acceleration time graph rarely they will ask. No need to, nothing questions will be there on this. Just 1 or 2 points they will ask. Acceleration time graph. Clear? So what they will ask? See, if a graph is drawn, by taking acceleration on y-axis. If a graph is drawn by taking acceleration on y-axis and time on x-axis, and time on x-axis is then it is called acceleration time graph. Then it is called acceleration time graph. What are the uses of acceleration time graph? Okay. So the slope of the tangent at any point. Try to remember. Displacement time graph slope at any point is giving instantaneous velocity. The slope of the tangent at any point for velocity time graph will give instantaneous acceleration. The slope of the tangent at any point gives jerk. Jerk means acceleration by time, that will be called as the jerk. It will give jerk. Velocity by time will be called dv by dt, will be called instantaneous acceleration. ds by dt will be called instantaneous velocity. dA by dt will be called jerk. The slope of the tangent at any point will give jerk. Okay. Next, the area of the graph will give change in velocity. The area of the graph will give change in velocity. Area means what I said. Area is equal to, you have to multiply the two quantities taken on the y-axis and x-axis. So area into time. We have to multiply two quantities. Then what will happen? Here what to do? We have to take area values on the acceleration values on the y-axis, time values on the x-axis. You have to draw the graph. A into t, this value v minus u by t into t, that value is equal to v minus u. So, what we will get, the area of the graph will give change in velocity. Okay. Shapes of the graphs are not required for this. Just remember up to this. Next. Yesterday we discussed about equations of motion. 4 equations of motion are there when body is moving with uniform acceleration. What are the equations of motion? V is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as, Sn is equal to u plus a into n minus half. Then how to derive that equations? Using velocity time graph. Theoretically, the theoretical part, questions will be there on this. Derive v is equal to u plus at using velocity time graph. Derive s is equal to ut plus half at square using vt graph. Derive v square minus u square is equal to 2as using vt graph. Like that questions will be there. How to derive them? Let us see. First, derive V is equal to U plus ET using velocity time graph. Okay, how to derive this one? See. Consider a body having initial velocity u moving with uniform acceleration a. A body is there, its initial velocity will be u. It is moving with uniform acceleration a. Body is there, one body. What is its initial velocity? U. Its acceleration is a. So acceleration means its velocity is increasing with time. Let V be the final velocity of the body after time t. Let S be the displacement. V be the velocity of the body after the velocity of the body is increasing. Body is moving with acceleration means what will happen? Velocity of the body is gradually increasing. After time t, V be the velocity of the body. After the time let S be the displacement of the body. If we draw the velocity time graph in this case, how the shape of the graph will be there? Let us see. Take time values on the x-axis, velocity values on the y-axis, draw a graph in this case. So how the shape will be there? Shape of the graph will be in this manner. Clear? So what it is representing? Body is having initial velocity. Body is moving with uniform acceleration. Clear? So this will be equal to u. This will be equal to v. This will be the time. Up to here, this will be the time. If we write the slope of the graph, what is the slope of the graph? I am taking this is O, this is A, this is B, and I am drawing a parallel for this. This is C, this is D, I am taking like this. Okay? Then what is the slope of the graph means? Slope is equal to this angle. Slope is equal to tan theta of that angle. If we assume this angle is theta, tan theta will be called as the slope of that graph. Tan theta is equal to how much? BC by AC. We don't know BC value, but we know BD value will be V. OA value is equal to U. That's why this value is equal to U. Understanding? This is U, but this will be also equal to U. Then BC value will be how much? V minus U. AC value is equal to OD. That value is equal to T. Is it understanding? So here time values I am taking. Here velocity values I am taking. If we draw the graph between velocity and time, graph shape will be like this. Slope of the graph, if I write, slope is equal to tan theta. From the graph, tan theta is equal to BC by AC. BC means V minus U. AC value will be T. Slope of the graph is equal to acceleration. A is equal to V minus U by T. From that, V minus U is equal to AT. Then V is equal to U plus E. So in this manner, we can derive V is equal to U plus AT using velocity time graph. Once again listen what I am saying. We considered a body having initial velocity U and moving with uniform acceleration A. Let V be the final velocity of the body after time T. Let S will be the displacement. In this case, if we draw the graph shape will be like this. In this graph, OA will represent initial velocity, BD will represent final velocity, and B equal to change in velocity V minus U. Slope of the graph means tan theta, BC by AC. This is change in the velocity by time. We got finally V is equal to U plus AT. Similarly, like this we can derive S is equal to UT plus half AT square. V square minus U square is equal to 2AS using this graph. Next class, how to derive them, we will discuss about that. Clear? Next. And in this class, what we discussed, just I recall for this in 2-3 minutes. So initially I discussed displacement time graph, taking displacement values on the y-axis, time values on the x-axis. If you draw a graph, that will be called displacement time graph. What are its uses? The slope of the tangent at any point gives the instantaneous velocity. The slope of that tangent, what is the second use? The slope of the chord between 2 points will give the average velocity. Next, if the shape of the graph is like this, what it is saying, body is at rest. Okay. If this graph shape is like this, body is at rest. If shape of the graph is like this, this is one. If the shape of the graph is like this, what it is representing, body is moving with uniform velocity. If body is moving with uniform acceleration, shape of the graph will be like this. Body is moving with uniform retardation, shape of the graph will be like this. Uniform retardation, uniform acceleration, uniform velocity, body at rest. So, in the same manner, for vertically projected body, this graph shape will be in this manner. Similarly, velocity time graph, if you take, if body is at rest, shape of the graph will be in this manner. Body is moving with uniform velocity. shape of the graph will be like this. Body is moving with uniform acceleration. Body graph shape will be like this. Body is moving with body or particle, whatever it may be. It is moving with uniform retardation. Graph shape will be like this. Okay? For vertically projected body, displacement time graph shape will be, velocity time graph will be like this. Displacement time graph will be like this. Next, acceleration time graph. Acceleration values are taken on the y-axis, time values are taken on the x-axis. If we draw a graph, that graph will be called acceleration time graph. Okay? Uses we discussed. Next, using velocity time graph, how to derive E is equal to U plus ATE. Up to that it is completed. We will continue the remaining in the next class. S is equal to UT plus half AD square. V square minus U square is equal to 2AS. How to derive from the velocity